When a program wants to use a file, it must open it first. Opening tells the operating system what you intend to do, and the operating system sets up a mode that controls the allowed operations. Read are like taking a book off a shelf to read it. The file must already exist. The program can only read data, attempts to write cause and error. In C, open data txtr. In Python, open data txtr. Write W like getting a fresh notebook. If the file exists, it is truncated, its contents are cleared, and a new empty file is created. The program can write but not read the old data. In C, open out txtw. In Python, open out txtw. Append like adding new pages to the back of an existing notebook. The file is created if it does not exist, but existing data is preserved and the file pointer is positioned at the end. Writes always add after the current last byte. Binary B adds a B to the mode string, for example RB, WB, a B. It tells the runtime to treat the data as raw bytes, not to perform any newline translation or character encoding conversion. Essential for images, executables, or any non-text data. Default behaviors. If no mode is supplied, which is rare, some languages default to read only. The language may assume read text. Always specify the mode explicitly to avoid surprising defaults. Understanding these modes is like knowing whether you are opening a door to look inside, to start a new room, or to add a new shelf at the back of an existing room. Every opened file has a file pointer, also called the file position indicator. Think of it as a bookmark that tells the system where the next read or write will happen. Tel returns the current offset in bytes from the start of the file. In Python, pos equals f.tel. In C, long pos equals ftel fp. It is like asking where is my bookmark now. Seek offset whence moves the bookmark. Whence equals 0 or seek set. Offset is counted from the beginning of the file. Whence equals 1 or seek cur. Offset is counted from the current position. Whence equals 2 or seek end. Offset is counted from the end of the file. Negative offsets move backwards. Example Python, f.seek 0, 0 go to start. Sequential access, you read or write continuously letting the pointer move forward automatically. Most simple scripts use this mode just like reading a newspaper page by page. Random access, you jump to any location using seek. Useful for fixed length records, databases, or binary formats where you need to edit a specific record without reading the whole file. Imagine a library where you can go directly to the 5th shelf instead of walking through the first 4. Proper pointer management prevents bugs such as reading the wrong line, overwriting data unintentionally, or infinite loops when the pointer never reaches end of file. Reading data from a file can be done in many ways, each suited to a different situation. Line by line, the most common for text, read a line, process it, then read the next. In Python, you can write for line in f or line equals f.readline. In C, you can write while f gets buffer size of buffer fp not equal null do something. Analogy, reading a recipe one instruction at a time. Block or chunk reading, read a fixed number of bytes at once, good for large files or binary data. In Python, chunk equals f.read 4096. In C, size tn equals freed buffer 1 block size fp. This is like scooping a bucket of water rather than sipping drop by drop. Reading into arrays or structures, when the file stores records of known layout, for example a struct person with a name array of 20 characters and an integer age. In C, you can do freed address of person size of person 1 fp. In Python, you can use struct.unpack after reading the exact number of bytes. EOF handling, end of file, tells you there is no more data. Functions return special values. Freed returns a count less than the requested number. Fief fp becomes true after an attempted read past the end. In Python, read returns an empty string. Always check for EOF after a read, not before, because the file pointer only knows it reached the end when a read fails. Choosing the right technique reduces memory use and makes the program easier to understand. File operations can fail for many reasons. The file does not exist, permission is denied, the disk is full, or the data format is corrupt. Detecting and handling these failures prevents crashes. Return values, most CIO functions return null or a count of bytes. Example, file pointer fp equals fopen-data.txt read mode. If not fp, then call pair open and exit 1. Fread returns the number of elements successfully read. Compare it to the requested count. Exceptions, languages like Python raise IO error or OS error. Use try except. Try open data.txt read mode. Accept OS error as E, print could not open file :E system exit 1. Validation checks. After opening, you may want to verify the file size get size or that the first bytes match a known header magic number. This is akin to checking a passport before letting someone board a plane. Graceful degradation. Instead of aborting, you can fall back to a default data set, ask the user for a different file name, or retry after a short delay. Robust code always checks the result of every file-related call before proceeding. When you are done with a file, you must close it. Explicit close, call the function or method directly. Fclose fp in C, f.close in Python. This flushes any buffered output, writes pending data to disk, and releases the operating system file descriptor, the handle. Automatic closure. Many languages provide context managers, or with statements that guarantee close is called even if an exception occurs. With open out txt write mode as f then f write hello, f is closed automatically here. In C++ RAII, a standard fstream objects destructor closes the file. Flushing buffers, output streams often keep data in a memory buffer for efficiency. Flush fp in C or f.flush in Python forces the buffer to be written immediately, useful before a crash-prone operation. Resource release. The operating system limits the number of simultaneously opened files, file descriptors. Forgetting to close can exhaust this limit, leading to too many open files errors. Think of it as leaving a door open. Eventually, the hallway gets crowded and no one else can enter. Always close files as soon as you no longer need them, or use language features that do it for you automatically. Text files store characters, binary files store raw bytes. The distinction matters for how the program interprets the data. Encoding. Text is encoded UTF-8 of SCII ISO 8959-1. When you read a text file, you must decode the bytes into characters using the same encoding the file was written with. Mismatched encoding leads to garbled characters, for example a tilde-e instead of e acute. In Python, you open the file with encoding UTF-8. Data representation. Binary files keep numbers in their binary form. For example, a 32-bit integer is 4 bytes. No translation occurs, so the file size is smaller and reading is faster. However, you must know the exact layout and endianness byte order. Example, writing an int in C with fwrite &x size of x 1 fp and reading it back with fread. Conversion considerations. When you move data from binary to text, for example exporting a CSV, you must convert numbers to their string representation and possibly add delimiters. Conversely, reading numbers from text requires parsing int line in Python, a to I in C. If you open a binary file in text mode, the runtime may alter newline characters, carriage return line feed to line feed, or stop at a Ctrl-Z byte, corrupting the data. Always match the mode to the file content. Analogy. Text mode is like reading a story written in a language you understand. Binary mode is like reading a sheet of music where each note is a precise pattern of bytes. Performance of file I/O depends largely on how you buffer data. Buffering. The runtime usually keeps a buffer, for example 4 kilobytes, that stores data read from or written to the disk in one system call. This reduces the number of expensive disk accesses. You can control the buffer size. Open big.dat rb buffering equals 8192 in Python, or setbuff fp null IOFBF 8192 in C. Read size selection. Reading 1 byte at a time, fget, is extremely slow because each call may trigger a system call. Reading in larger chunks, for example 4 kilobytes or 64 kilobytes, amortizes the overhead. The optimal size depends on the underlying hardware and operating system page size, commonly 4 kilobytes. Algorithmic complexity. I/O does not change the big O of your algorithm, but the constant factor can dominate runtime for large data. For example, scanning a 1 gigabyte file line by line has O of n time, but reading in 64 kilobyte blocks can be 10 to 100 times faster than reading 1 character at a time. Memory mapped files. Some operating systems allow mapping a file directly into the process address space. mmap. This can give the illusion of random access with minimal copying, useful for huge read-only datasets. Practical tip: profile with realistic data. If a program feels sluggish, first increase the buffer size or switch from character by character to block reads before rewriting the algorithm. Overall, treat the disk as a slow robot arm. Give it a big pile to carry each time instead of handing over a single coin. Suppose we have a text file numbers.txt containing one floating point value per line. 12.5, 7.3, 9.0, 15.2. We want to compute the mean mu and variance sigma squared of the numbers. Algorithms. Open the file for readings. Initialize count equals 0, sum equals 0.0, sum underscore sq equals 0.0. Read each line, convert to float x. Count plus equals 1. Sum plus equals x. Sum underscore sq plus equals x times x. After the loop, compute mean, mu equals sum divided by count, and sigma squared equals sum underscore sq divided by count minus mu times mu, the shortcut formula. The variance definition is sigma squared equals 1 over n times sum of xi minus mu squared. Expanding the square, sigma squared equals 1 over n times sum of xi squared minus 2 mu xi plus mu squared. Since mu equals 1 over n times sum of xi, the middle term becomes 2 mu equals 2 mu squared. Hence sigma squared equals 1 over n times sum of xi squared minus mu squared. This matches the shortcut formula used. Sample Python implementation. Import maths. With open numbers.txt read mode, as f:\initialize count equals some value equals some sq equals 0. For each line in f:\convert line strip to float x increment count by 1. Add x to some value. Add x times x to some sq after loop, compute mean equals some value divided by count. Compute variance equals some sq divided by count minus mean times mean. Print mean and variance formatted to 2 and 4 decimal places. Extension matrix reading. If a file stores a matrix in row major order, you can read each row into a 2D array while computing row sums, column sums, or performing Gaussian elimination. The principles of sequential reading and numeric conversion remain identical. Multiple choice, choose one. Which mode will append data to an existing file without truncating it? Option A, R, option B, W, option C, A, option D, RB. Answer, C. True or false? A file opened with mode RB will automatically translate \r\n to \n on Windows. Answer, false, because binary mode disables newline translation. Code trace in C file pointer fp equals fopen open double quote data.bin double quote comma double quote wb double quote semicolon. Integer a equals 0x1234567 comment 4 bytes. Fwrite address of a size of a 1 fp fclose fp. Then fp equals fopen open double quote data.bin double quote comma double quote rb double quote. Fseek fp2 seek set. Integer b, freed address of b11 fp, print double quote %02x\n double quote b fclose fp. Question, what hexadecimal value is printed? Explanation. The file contains bytes 78, 56, 34, 12 on a little endian machine. After seeking 2 bytes, the byte read is 0x34, so the output is 34. Short answer. Explain why it is important to check the return value of freed before using the data. Key points. Freed may read fewer elements than requested when end of file is reached or an error occurs. Using uninitialized data can cause incorrect results or crashes. Fill in the blank. In Python, the statement with open single quote log.txt single quote comma single quote a single quote as f: guarantees that the file is closed when the block ends. Answer, closed and flushed.